Alright, hey, today we are here to talk about what causes our climate to change. And really, if we boil it down, there are three different big categories that could cause climate change. The first one is just simply energy input from the sun to Earth. The sun is our energy source, so if there's any fluctuation in the amount of energy the sun is putting out, that would mean that Earth is receiving more or less energy itself. Another very important factor is what sort of energy is reflected. Depending on Earth's surface and some factors in our atmosphere, solar radiation could just simply be reflected before it was absorbed in the first place. And the amount of reflected energy actually changes over time as well. And the last piece of the puzzle is energy absorbed. How much energy gets absorbed by our atmosphere and absorbed by greenhouse gases like we talked about. The sun and all stars evolve over time. So when Earth first formed, the sun actually produced something like 70% of the energy it does now. And over Earth history, it has increased the amount of energy it releases. So Earth has been absorbing the input to Earth's systems has been increasing over time. But as the sun's energy output increased, our atmosphere changed. Back when the sun was weaker, we had more greenhouse gases keeping our planet warm. But as the sun's energy increased and we received more solar radiation, our atmosphere changed and we ended up having less and less greenhouse gases, which kept our temperature at a moderate level. When we talk about energy that's being reflected, one way that happens is through major volcanic eruptions and meteor impacts. Both volcanic eruptions and meteor impacts, they end up putting debris in our atmosphere. Either volcanic ash that can actually spread around our entire planet, or in the case of an impact, it would be just dust. And this ash or dust acts like a blanket and blocks out, reflects back into space, solar radiation. So this would mean the planet would be receiving less energy from the sun, meaning there would be a cooling trend after major volcanic eruptions or these massive meteor impacts. And when we talk about energy being absorbed, that's really talking about our greenhouse gases. And the amount of greenhouse gases has fluctuated over time. And one way that happens is through the deposition of limestone. Limestone is made from calcium and carbonate, which is pretty much dissolved CO2 from the atmosphere in ocean water. And so when we deposit these limestone rock layers, what we're really doing is we're removing CO2 from the atmosphere and we're trapping it in rock layers under the seawater. And that's one natural way to reduce CO2 in the atmosphere. And the ocean is actually called a CO2 sink, a carbon sink, because it removes so much CO2 from the atmosphere and is kind of stored for a long period of time in these rock layers. And one of the most impactful causes of climate change is actually something dealing with Earth's position in space. There are several different changes to our orbit or how Earth is moving around the sun that can really affect the climate of Earth. The first one is obliquity, or really just the degree at which Earth is tilted. And if you know anything about the seasons are caused by Earth being tilted toward or being tilted away from the sun, depending on which side of our orbit we're in. And when Earth is tilted towards the sun, that means like our northern hemisphere would be in summer. And when our axis is tilted away, that means northern hemisphere would be in winter. But as our axis gets more upright, we would have less of a change between summer and winter, therefore changing the climate of Earth. And when our axis is tilted to its maximum, there would be a more drastic change between summer and winter. Another change to our position in space is called precession. And this is simply just the wobble of Earth's axis, kind of like a top that you spin on a table. And as it slows down, that top will wobble. If you imagine a laser pointer pointing out the top of the top, the laser would be drawing a circle on the ceiling as that top slowed down right before it tips over. And Earth is doing the same thing. Our axis is wobbling and it's moving, and it's really drawing a large circle in space. And right now our axis points towards the North Star. It points towards Polaris. But in the future, when we have some wobble taking place, Earth's axis and the North Star will change. Our new North Star will be Vega. And this precession alone, it doesn't really change our climate. But right now, currently, the way Earth is rotating around the sun, Earth is actually physically closer to the sun during our winter, like when it's freezing cold. But because we are tilted away from the sun, we're still in winter. And that means during summer, when it's, warmer temperatures, it's because we're tilted towards the sun, but we are physically further distance from the sun during our summer. But with precession, that will all change. After precession takes place, when we are closer to the sun, we'll also be tilted towards the sun, meaning northern hemisphere summers are going to be a lot warmer. And during winter, when we're further from the sun and tilted away from the sun, our northern hemisphere winters will be much colder. So again, precession by itself is not going to change the climate. It's that precession paired with our distance from the sun. That's where we're going to see some climate change. And our last orbital variation is called eccentricity. Eccentricity is the shape of Earth's orbit. Sometimes we're more elliptical, and that elliptical orbit is a less constant solar radiation, meaning Earth's climate is going to cool off. And when it becomes more circular, we get a more consistent solar radiation, and it's going to cause a warming trend. And right now, Earth is currently moving towards a more circular orbit. So it would make sense that Earth is warming up. And hopefully from this part of the notes, you're starting to understand that there are a lot of natural causes of climate change. We've seen through Earth's history that Earth's climate has changed a whole lot. And there's evidence right now that show there's natural causes to Earth warming. But there's also some data to show that people have made an impact here as well. And that's what we're going to talk about soon. If you have any questions, please make sure to ask. Otherwise, make sure you're taking some really good notes here. And I'll talk to you later.